my grass is really long. And you're like, I don't want to cut the grass. That's so hard. I have to push around a lawnmower. Well, fret no more, because look at this. The purpose of this is to mow grass for you, just automatically. You put out the boundary fence. Right here, we have the transmitter powered by this battery right here. We also have an output, the LED, just to indicate that it is on, as well as a speaker that starts playing when digital 9 reads high. We have a switch here that turns it on. So what's going on here? Here is our 4 megahertz quartz, which acts as the clock for our binary counter. Our most significant bit is grounded, so we're using the second bit, which is dividing the clock signal and then transmitting that to the fence. So when I flip the switch, and if I turn it off, we got our sensors. Right now, we're only testing the leftmost sensor. The idea with this circuit is that we have these 2 inductors, which are going to be able to sense if the lawnmower has driven over the boundary fence. If we go here, you can see that it's printing data. Now, the main problem with the inductive sensors is that even though they're printing values, the frequency of the inductive sensors doesn't exactly match the frequency of the boundary fence. Now, this could be due for multiple reasons, but we sum it up to the fact that we had to make some last-minute component changes. We don't have an oscilloscope or a frequency meter, which would allow us to measure the frequency of each sensor and then adjust accordingly by a guess and check method so the frequency matches. That being said, this means that the lawnmower and the transmitter aren't able to effectively communicate. If we go over here, here is our lawnmower circuit as a whole. We have the 2 inductive sensors on the front, both of which have 2 inductors each. The goal being to have 2 that are in the front from each side to be able to sense when the boundary is in front of the lawnmower, and then 2 that are also on the sides that are able to sense when the boundary fence is on the side of the mower. Down here we have our 12-volt battery as well as our 24-volt battery. The 12-volt battery is connected directly to this capacitor for load management, and then that is connected to this driving motor, which then goes to these motors, and that can control the voltage going to each motor. Additionally, we modified the motor driver, so we have pin 1 and 15 attached here. Those are attached to analog down here through this resistor bridge. That way we can actually analog read the values going through the motor driver. That way we can manage the load going to the motors. The other battery runs up here through this transistor diode system, which runs to the cutting blade. And right here we have everything hooked up to the Arduino, which all runs through this board here. And that controls everything.
Hey, Group Mike here. This is the main body of the lawnmower. And as you can see, we have a large motor here. This powers the weed whacker. And then we have 2 hidden motors down here that are driving wheels. So to start the system, we're using just some leads for the weed whacker. So I'll go ahead and start that. You can hear it go. And I'll lift it up a little bit so you can see the system working. And then to start the driving, we just flip this switch here and it'll just kind of go on. Just start moving like that.
This is Team Mike. Thanks for watching.
Thanks for watching.
Thank you for watching.
Thank you for watching. Thank you, Mazen, for filming.
Thank you, Mazen.
Thanks, Mazen.